nerd.
Episode of our Tower Unite laser projector tutorial. This series will show you how to use the laser projector to its full potential by explaining the coding system behind it and how to use it effectively. Each video will build on top of the last, so I recommend you watch these in order to get the full experience. This series of videos is perfect for furries, weeaboos, any member of the Tower Unite community. Out of all the creative things you can use in Tower Unite, the laser projector has the most untapped potential. Very few people know how to use it effectively, and those who can are able to create some pretty cool things. They can be useful, or they can be pretty, or they can be a combination of the two. There's a pretty disappointing lack of laser creations in the condos I've seen, and I want to change that for the better. So let's begin.
Welcome back to That New Condo. I'm your host. Today we found this old house in a scenic utopia with privacy all around. In the back, we have this lovely old oak tree. It was an original staple of the property, and it's 293 years old. We figured out how old it was by cutting it down, counting the rings, and gluing it back together. Our tree guy assures us it will be okay. The living room boasts beautiful ceiling doors, allowing natural sunlight to radiate into the room and wrap you into a cradle of comfort. Masking off your deep onset depression, we don't enjoy reminding you.
What the hell's wrong with the TV? I thought I got this thing fixed yesterday. Oh well, back to lasers, I guess. In today's episode, we're gonna talk about functions and operators.
Woo! Woo! Functions! Functions for the win! Woo! Woo! Oh! 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 Oh!
Every function has the same basic structure: a word or term, an open parenthesis, some stuff in the middle, and a closed parenthesis. The function is applied to whatever is within the parentheses. The stuff in the parentheses is known as the argument. The arguments can be anything from a discrete number to a variable to another function. It just has to be some sort of number. Some functions require two or more arguments separated by commas. Let's go over the different functions we can use in the expression editor. In order to show some of the different functions' purposes, I will use some code to essentially graph the functions with lasers. There are many functions available that you probably learned about in math class. Square root, denoted by sqrt, and absolute value, denoted by abs, are both available. They simply return the square root or absolute value of the number inside. By the way, if you didn't know, absolute value just makes a negative number positive. Arctangent actually has two forms. By putting 2 after tan, we can use the second form, which actually requires two arguments, both an x value and a y value. This is to avoid divide by zero cases, in which you may be trying to take the inverse tangent of a value that has been divided by 0. The purposes of the next few functions can't really be shown with the graph, so I'm just going to say straight up what they do. First is min, which simply compares two numbers and outputs the smallest of the two. So for example, minimum of 1 and 2 simply yields 1. Based on that, I'm sure you can guess what max does. It just returns the largest of two numbers, so max of 1 and 2 is just 2. Then there's floor, which basically cuts off the decimal part of a number, or in other terms, it rounds the number down. So floor of 3.14 will yield 3, because it either cuts off the decimal or rounds it down, whatever you want to think. Then there's ceil, or ceiling, which does something similar, except it simply just rounds up. So for example, the ceiling of 3.14 will be 4. And then of course there's round, which basically just does either floor or ceiling depending on what the number is. It just rounds the number to the nearest integer. So for example, the round of 3.1 is 3, and the round of 3.9 is 4. As you can see, 3.1 is closer to 3, so it rounds to 3, and 3.9 is closer to 4, so it rounds to 4. Then the last one is called random, or rand, and it's not really a function. You don't put anything in the parentheses. It just outputs a random number between 0 and 1. So if you want to use it, you just have to put rand, open, close, parenthesis. You don't really put anything in there. It just works on its own. The if function is the laser projector's version of if-then statements, but it works a bit differently. Remember, the expression editor's main purpose is simply to output values to be interpreted by the lasers as position. Therefore, the if function's purpose is simplified. If a number is 1 or bigger, then it returns A. If not, it returns B. This may seem a bit limited, but with some creativity and tinkering, it can be very useful. And in the later episodes, when we actually go through codes and start to make our own programs, it will be used quite a bit for some things. Finally, there is interpolation, or lerp for short. Now, this is kind of a weird function. It's very useful, but it's not really possible to show like what it does just by explaining it. I need to show some examples of it, but I am going to go into a little bit of the technical side just for a little bit, so those mathy kinds of people can more easily understand what this might actually mean. So basically what it does is that it returns the value a fraction of the way between A and B. So its general formula here is just A plus the difference in B minus A times the fraction. So as I said before, it takes A and then it goes fraction of the way between A and B and it returns that value. So here's a couple of examples of it being used. So the interpolation of 0.1 from 1 to 2 is 1.1. And as you can see, the function just went 0.1 of the way from 1 to 2. And in that case, that's 1.1. Another example would be interpolation of 0.5 from 0 to 360. As you can see, it just goes half of the way from 0 to 360, so we get 180. And finally, we have the interpolation of 0.5 from 5 to 10. That should be a comma there in between the 5 and the 10. Sorry about that. And as you can see, it yields 7.5 because it went 0.5 of the way from 5 to 10. So here I have a circle made of lasers. I'm not going to go over how I made this circle right now. I'll probably go over that in a little later video. But what I want to do is assign a different color to each laser. Now, a naive person would probably look at the fact that there are 49 lasers in this expression and then probably write some weird complicated expression to assign a different color for each laser based on the fact that there are 49 lasers. But I want an expression that will actually assign each laser a different color regardless of how many lasers there are in the expression. So we will use an interpolation function for that. So I will do lerp and an open parenthesis. And if I want each laser to have a different color, we need to use a data value that is different for each laser, but is also a fraction. And we have exactly that type of variable, which is just fraction. So we will make that our fraction, the first number in the function. And now, as you may remember, the hue goes from 0 to 360. So we would do 0, comma, 360, and then a close parentheses. Now, right now it's white, and that's just because I haven't set the saturation. And there we go. As you can see, every laser has a different color, and it creates this nice sort of rainbow effect. And now I can change how many lasers there are in the expression all I want, and every laser will always have a different color, and it will always make a perfect rainbow all the way around. I can even set it all the way up to 20 by 20. Now it just looks like a cool, solid rainbow ring. So yeah, that's it for the functions. Now we will move on to the operators, the things that really tie things together, tie all the functions and the numbers and all the expressions together in our codes. Our final topic for this episode is operators. These are basically just mathematical symbols that manipulate numbers in some way. That might sound a bit strange, but once we go to the next slide, you will immediately understand what those are. So first we have the 5 most basic ones. They are just plus, minus, times, divided by, and raising to a power. And they do exactly what you think. You can add numbers, you can subtract numbers, multiply numbers, divide numbers, and raise numbers to powers wherever you want in the code. The next operator is just a percent symbol, and it's called the mod or modulo function. And basically what it is that it divides a number by another number, but it only returns the remainder. So for example, 10 modulo 3 is 1. As you may know, you can't evenly divide 10 by 3 without getting like an infinite decimal. 10 divided by 3 is 3.33333 to infinity. So what this does instead is returns the remainder. If you add up 3 repeatedly until you can't add it anymore without going over 10, 3, 6, 9, in order to get to 10, you need to add 1, and that is the remainder. So 10 modulo 3 is 1. If we have 10 modulo 2 instead, we can add 2 up repeatedly, 2, 4, 6, 8, 10, and get exactly to 10. So since there is no remainder, since 10 can be evenly divided by 2, the remainder is 0. So 10 modulo 2 is 0. If this is still a bit complicated, there will be a link in the description for a modulo calculator that will allow you to sort of play around with this and kind of gain an intuition for what this really is and how it works. The equal sign assigns the value on the right side of the sign to the left value. This is for assigning variables. So as you may know, if you want to make a new variable, you type in the variable equals and then the value. So that just assigns the right value to whatever's on the left. That assigns the value to a variable, for example. This next one is a pound sign, and it is used for comments. Whatever is after a pound sign on a line is completely ignored by the code. It is simply just to make little notes in the code in case you want to like explain the code to another user, or if you want to like make notes for yourself if you're trying to keep track of what the code does. Just whatever you put in there is not going to be used by the code. You can make little notes, you can make little explanations, whatever you want. So these last operators are not really like the past operators. These are conditional operators. They compare two numbers to see if the condition based off of the operator is fulfilled or not. And if the condition is fulfilled, it outputs the number 1. But if it is not fulfilled, it outputs the number 0. Now, if you remember back to the if statements, remember whatever they did was based off of if a number was 1 or not. And so that's exactly what that's based off of. It's based off of conditional operators. So now with the if statements, we can put in a conditional argument, and whether it outputs 1 or 0 can decide what the if statement does, just like any other if statement in any other coding system. So first we have less than and greater than, which basically just sees if the number on the left is less than or greater than the number on the right. And if it is, it outputs 1, and if it isn't, it outputs 0. Then we also have less than or equal to and greater than or equal to, which does exactly the same as the last ones, but it also outputs true if the two numbers are equal. And then we have the double equal sign. You may remember the single equal sign from earlier in the video. That is not the same. That is only used for assigning values to other values. This is only used to check if one value is equal to another. Do not confuse them. So then we have these three, what I like to call meta operators, and, or, and not. What you can do with these is actually put a conditional argument on the left and the right, and it will output 1 or 0 based on whether both of them are true, one of them is true, or neither of them are true. So with and, if you put two conditions, one on the left and one on the right, both of them have to be true for it to output 1. For or, only one of them has to be true. And for not, none of them have to be true. Not is somewhat special because while it can be used to compare if one condition is not equal to another condition, it can also be used to compare two values. Like if we could put like a variable on the left and a number on the right. If the two are not equal, it outputs 1, and if they are equal, it outputs 0. So that is the end of episode 3. Today we talked about functions, which are used to manipulate data, and operators, which are also used to manipulate data, but in simpler ways. So next episode, we will probably actually begin to go over some of the strategies and methods that we can use to accomplish different things with the laser expression editor. So yeah, that'll be pretty cool. I will see you in the next episode. Thank you very much for watching.
Have a good day.